Hi guys, welcome back to the channel. My name is Jag, and in today's class we are going to continue with our grade 9 content. So we're going to move on to the geometry section. Okay, and as you can see, today's class is going to cover the surface area of a cone. And within the geometry unit actually, because there are a lot of formulas, the teachers will provide you with the formulas on your unit test as well as the final exam. The grade 9 EQAO does focus on the geometry section a lot, okay, and there's basically a standard formula sheet that will be provided, and if you want to take a look at that, you can actually go onto Google and just put it into the Google search box. Okay, with that, let's get started. All right, so what I'm going to do is write out the formula for the surface area. We're going to try this example on the board. Okay, so let me write out the formula for everyone. So this is the surface area equals pi r s, okay, and s here basically is denoting the side, okay, or the slant of the cone, okay, plus pi r squared, and the pi r squared you can see represents basically the circle that is on the bottom of the cone. All right, and this is given here. This is the radius, which is 10 centimeters, okay, and the slant height of the cone is 30 centimeters. Alright, so what we're going to do, make sure you have your calculator handy, okay? A lot of calculations within the geometry unit, just like when it was covered also in grade 8. Okay, the value for pi we're going to use is 3.14. So I'm going to put this in brackets, so 3.14, okay, times the radius, which is 10, times the slant height, which is 30, okay? And I always put it in brackets, okay, just to make sure I'm doing each of these values separately. You're multiplying it and then you're adding it together. Okay, so in the second bracket it's pi, so 3.14 times r squared, okay, and r is equal to 10 here, so I'm going to do times 10 squared. So for the geometry section, the teacher does want to see all of your steps here, just in case you end up with the wrong answer, and that is possible as well, okay, because you're doing a lot of calculations here. So I'm going to put this into my calculator. Okay, we're doing 3.14 times 10 times 30, and we're getting 942. And then you're going to go to the next bracket. We're doing 3.14 times 10 times 10. And I'm going to do that 2 times so we don't get confused here. That's what 10 squared is, okay? It's 10 times 10. So like you're multiplying it by 100, okay? And then you're going to just do 942 plus 314, as you can see, and we're getting 1,256, okay, centimeters squared. All right, and don't forget to put the centimeters squared, okay, because again, this is surface area. Whenever you see the term area, your final answer must be squared, okay? And make sure you're just watching the units again. So again, the centimeters is the most common units that's used here. Does not mean that the teacher doesn't put in the meters, just to try and trick you. Sometimes the question is giving you these components and values in meters, and I see students writing their final answer in centimeters squared. Okay, and so the teacher can take off a mark and will take off a mark for something like that. All right. Alright, that looks good. Okay, so with that, let's try one more example here. Okay, so I hope everyone understands how to use the formula. Okay, so now there are just a few variations to using this formula and finding the surface area of a cone. So I'm going to take this off. Okay, we're just gonna leave the cone here, okay, or the picture of the cone. Alright, so this time, okay, it says calculate the surface area of the cone to the nearest square centimeters. Okay, so basically, what's given here is 8 centimeters, okay? And the radius is given as 3 centimeters, okay? And this is actually, what's given here is actually the height, okay? So you notice right away that I cannot plug all these values into my actual formula. I need to know what the slant length is of the cone. And how you do that is I'm going to just make a square, okay? If you notice, this is basically a right angle triangle, and I can use the Pythagorean theorem in order to find my slant length, or slant height, okay? And again, if you're not sure how to do this, please make sure you're checking out one of my previous videos. It's on the Pythagorean theorem, how to solve for the longest side of the triangle, which is the hypotenuse, or how to solve for basically one of the legs of the triangles. And remember, because it's a right angle triangle, okay, the legs of the triangle are always going to be shorter in comparison to the hypotenuse. All right. So for this, I'm just going to make the slant as S, and let's just put question mark. Okay. So I always do this in like two separate steps. Okay. So in the first step, what we're going to do is we're going to use the Pythagorean theorem. So S squared equals 8 squared plus 3 squared. Okay. So just like this. And then notice, because the slant length of the cone is side C basically, okay, this is representing the hypotenuse, and that's the reason that we are adding, okay, the other sides together. So we're doing 8 squared, so 64, plus 3 squared, which is 9. Okay, and don't forget to take the square root at the very end. Okay, so this is going to be 73. Okay, I'm taking the square root of 73 on my calculator. Okay, we're going to round that, and I'm getting 8.5, okay, centimeters. Okay, this is the side length basically of our cone here. And now, because I have the side length, I can actually plug this into my formula for surface area. So for surface area, you could just write SA equals, okay? Some people like to write like SA of the cone, something like that. That's okay as well. And the reason for that is later on you're going to be doing like 3D shapes, and the shapes might involve different things like the cone. There can be a cylinder or a rectangular prism, and that's the reason I would denote it like this. Okay, and the question might just ask you to find the surface area of that entire shape. Okay, so you want to make sure each of your calculations is very distinct. Okay, so it's pi r s plus pi r squared. Okay, I'm going to just plug in the values I have into this formula here. Again, put it in brackets, so 3.14, okay, times the radius. The radius is given here, which is 3. Okay, times the side length that we found in step 1, and we got 8.5. Okay, so you notice I have to do step 1 before I can move on to step 2 and actually calculate the surface area of the cone. Okay, and in the second bracket, we have 3.14. Okay, times the radius squared, again, which is 3 squared. Okay, and then you're going to do each of these calculations separately. So let's multiply it. 3.14 times 3 times 8.5. Okay, again, I'm not going to round it until the very end, so I'm getting 80.07. Okay, plus 3.14 again times 3 squared, so it's times 3 times 3. Okay, 2 times. So we're going to do plus 28.26. I'm going to add both of these numbers together, okay? And I'm getting 108, okay, centimeters squared. So again, the question did say to round it to the nearest square centimeter, okay? So we're rounding it to I got 108.33, and we're going to round that to 108, okay? One more time, do not forget to put the units down, okay? So here it's going to be centimeters squared, okay? So at the same time, so this formula can be used, okay, to calculate maybe like the radius or like the side length. I can also just use this formula to do that, okay? And sometimes teachers will just provide you with the surface area of the cone, okay? And they'll ask you to solve for one of the variables, okay? And most likely it will be the value of S, which is the slant height, okay? And the teacher can give you the surface area of the cone, and then basically the radius can be given. And then because I have just one unknown now, okay, I can actually solve for the value of S, okay? So that's also like a variation to this question. And there's a lot of different questions in the textbook, which are just variations of using the exact formula, okay? So again, especially in the application questions, make sure you're trying a lot of practice questions from the textbook, and that way you'll get really good at using the formulas. And once again, I don't need to memorize the formulas at the grade 9 level, just because compared to grade 8, There are so many different formulas here, and teachers don't want you to actually memorize the formula. Okay, they want to make sure that you know how to apply each of these formulas when they give you the unknown values. All right, and again, make sure you go online and check in on Google for the formula sheet that's going to be provided for the grade 9 EQAO. All right, and again, make sure you're doing a lot of practice questions. There's some practice tests for EQAO online, and I would make sure I'm doing all the questions, because most of the questions on the test are very similar to the questions that were there from the previous years. Okay, so it's a really good practice for that. Alright, so if there are no questions, that brings this video to an end. And basically we covered the surface area of a cone in the geometry unit for grade 9. Alright? And again, if you did learn something and you enjoyed this content, please make sure you're subscribing to the channel and click on the like button below, because that makes a really big difference. So thank you for watching, and I will see everyone in the next video. Bye!